Welcome back to part 4 of our Ram Camp project. Before we can start building out the interior of the van, I need to wire the power center, install 2 inverters, the lithium battery, and finish the solar installation. That's a lot of wiring, so we better get busy. We are starting with the power center. That means we are connecting all of our 12 volt and 120 volt loads to the power center, and we will connect our shore power cord to the power center after we install the power inlet in the van. This is our power inlet. It's the part that our 120 volt detachable power cord plugs into when the van is plugged into electricity. Once installed, it will connect to the inverter and then go out to our WIFCO power center. The first step is deciding where to mount the inlet on the van. I prefer to keep the wiring runs as short as possible, so it would make sense to mount it at the rear corner of the van. Now we can cut the opening. Mark the outline where you want to cut the inlet. Check that nothing on the inside is in the way. Use a hole saw if you have one large enough, or you can drill a hole large enough to get a jigsaw blade through and carefully cut the opening. Before we mount the inlet, we are attaching our wiring that goes to the inverter. Follow the instructions to make proper wire connections. It's important that you torque the screws to 20 inch-pounds. Place the inlet in the hole, align it, and mark the mounting holes. Drill small pilot holes and mount the inlet on the van.
We wanted to have several options for electrical power in the van based on different camping scenarios. If we have access to electricity, we can plug in and use the power source. Now for boondocking and the sun is plentiful, we have 2 solar panels, an inverter, and a lithium battery. If we are boondocking and the sun is not available for a day or two, we have a 3200 watt quiet generator. Now that sounds like lots of wiring, so somebody better get busy.
Now the wiring can begin. We'll start at the power center, then our lithium battery, then the inverter and the charge controller. I mentioned in a previous episode our WIFCO 8900 AD power center has the patent-pending auto-detect technology. This new microprocessor recognizes what type of battery is used in the system and automatically adjusts the charging profile to match the battery type. That is a great feature, especially with our 250 amp hour lithium battery by GoPower. Let's start wiring things right now. Caution: prior to doing any wiring, make sure no power source is turned on and remove all jewelry. The DC fuse board has spaces for 11 DC fuses, and there are a total of 10 AC breaker slots if you use duplex breakers. You need to know the load on every circuit so you know what size fuse or breaker to use. I made a list of what we are using in the van with load requirements, so I know how to size the fuses and breakers. We have our power inlet and cable installed, so we can start the wiring by connecting the power cord to the inverter and then go out to the 30 amp breaker in the power center. Then connect the black hot wire to the breaker, the white neutral wire to the neutral terminal, and the green ground wire to the ground terminal bar. Route all the branch circuits the same way and make the hot, neutral, and ground connections the same way. Now route an 8 gauge or larger green or bare wire through the hole next to the ground bar and connect it to the negative post. The opposite end goes to the vehicle chassis ground. All the ground connections are extremely important, so make sure you use the proper gauge wire and that the connections are secure.
Here's an RV 101 pro tip. Make sure you label the breakers and the fuses in the proper order for future reference.
It's important you follow the torque specifications in the instructions. If the screws are too loose, you can have a poor connection, and if they're over tightened, it can damage or break wires. Torque the screws to the proper torque in inch-pounds. Now we can start wiring the 12 volt fuse side of the power center. Make sure the battery is disconnected prior to starting the DC wiring and remove any jewelry. Connect the heavy wire, red, coming from the battery to the positive lug located directly below the reverse polarity fuses. I have my list of DC loads with the fuse sizes I need. These are the output screw terminal connections. Just strip off about 1/4 inch of insulation from the load wire and insert it into the screw terminal. Tighten the terminal to the torque specified in the instructions. Connect the remainder of the DC load wires the same way. The last step on the 12-volt side is to install a separate bus bar in a location behind the converter. We need a minimum of 8-gauge wire to go from the negative lug on the top left of the DC fuse board to this bus bar. Now connect the battery negative wire to this bus bar along with the negative DC load wires. Then run a wire from the bus bar to a chassis ground. Now I can install most of our light fixtures, the USBs, the GFCI, the water pump switch, AC heater kit, and the 120 volt outlets.
That completes the 120 volt and 12 volt wiring at the power center. Now we can finish our Go Power solar, inverter, and lithium battery installation.
Sizing a solar system for your specific needs is not that difficult. Start by determining the average number of days you plan to be off-grid. Then figure out the average 12 volt and 120 volt amps you'll use per day. Now you can multiply the number of amps used per day by the number of days of use per week. That number determines the approximate size solar kit you need. Our goal with this van camper is to build a weekend off-grid camper. A weekend could be 2 or possibly 3 days a week. When we did the math, we needed the 380 watt solar elite system. Go Power offers lots of useful information on calculating and sizing a solar system based on your needs. The first thing I want to do is install our cable entry plate on the roof and seal all our solar panel mounting bolts. To seal the wires and plate, I'll use butyl tape and a die-core sealant. Tighten the screws until you see butyl tape coming out around the edges. Remove the excess butyl tape and seal the perimeter and screw heads with the lap sealant. Finish by sealing all the bolts that went through the roof. Now we can install our Go Power solar charging kit. The way this works is the 2 solar panels on the roof converts the sun's energy into DC electricity, which charges the lithium battery. The battery stores the electricity until it's used to operate devices in the van that are connected to the battery. We are also installing a 2,000 watt Go Power inverter that will change 12 volt DC power from the battery to 120 volts so we can use those devices when we're boondocking. This is just an overview, not a how-to installation. We already installed the solar panels on the roof, so we can start with our charge controller. The charge controller or regulator prevents the battery from being overcharged by the solar panels. For safety purposes, disconnect or cover the solar modules and make sure all power is disconnected. Run the solar module power cable to the location of the regulator, but do not connect the wires to the regulator or the battery at this time. Identify the polarity of the wires and avoid reverse polarity. Mount the regulator relatively close to the battery, but where you can access the connectors and monitor the system. Cut the positive and negative cables to length. Strip the wires and wire the regulator according to the terminal identification on the back of the regulator. Wires must be run from the solar module to the regulator and then to the battery. Tighten all connections. Decide the best location for the 30 amp fuse holder in the positive cable. Splice the fuse holder and positive cable together and use a heat gun for the heat shrink over the connection. Leave the 30 amp fuse out for now. Let's talk briefly about inverters. An inverter takes 12 volt DC power and inverts it to 120 volts AC. There are small inverters, say a few hundred watts, to much larger inverters like 3,000 watts. And there are inverters that are easy to connect and others that are more difficult. We're using 2 inverters in the van. Let me explain why. We have a 2,000 watt inverter by Go Power that has 2 GFCI connections on the back. You just connect the inverter to the battery, making sure to include the correct type fuse, and you're basically done. When you want to use the inverter, just plug into the GFCI or run an extension cord, and you have close to 2,000 watts of AC electrical power. On the other side, we have a WIFCO 2,000 watt inverter that you connect to the battery the same way, but rather than coming with a built-in GFCI, this one is hardwired into the power center. It has a built-in relay that prevents it from using shore power and the inverter at the same time. So this inverter is connected to all the 120 volt circuits in the van, but keep in mind you are still limited to a little under 2,000 watts of AC power, and how long you can use the AC power depends on the battery. For example, our 250 amp hour battery can provide 5 hours runtime at 50 amps, or 2 hours runtime at 125 amps, or about 1 hour runtime at 230 amps. So you need to be aware of the amps you are using and how long you use it. Then of course you need to consider how the battery or batteries are being charged. We have 2 solar panels that charge the battery, and when we're plugged into electricity or running the generator, the auto detect charger by WIFCO charges the battery. Now let's take a quick look at how all of this is configured. I mentioned a charge controller is basically a regulator that prevents overcharging the battery from the solar panels. Our inverters are connected to the battery with a properly sized fuse on the positive side. Inverters should be located as close to the battery as possible. RV 101 pro tip: if you're using lead acid batteries, the inverter cannot be in the same compartment as the batteries because of off-gassing. It's important you use the properly sized cables, and any crimps you make are done correctly and secure. The size of the cable should be thick enough to limit the voltage drop to less than 2% when carrying the maximum input current. Always follow the manufacturer instructions and adhere to all cautions and warnings. I want to talk about battery disconnect switches for a minute. In all installations, a battery disconnect switch is required. When you put your RV in storage, you want a battery disconnect to prevent parasitic drain on the battery. But with solar panels, if you disconnect the battery while the charge controller is connected, it can damage the controller. So I decided to put one disconnect switch between the solar panels and the charge controller, and a second one to disconnect the battery when the van is in storage. To help monitor all these devices, there are remote controls and monitor panels. We have an inverter remote here for the Go Power inverter. What's really cool is now we can operate the inverter right here at this panel rather than having to get under the bed to turn it on and turn it off. Then you've got your output power. So if I was using the inverter right now, it would tell me how much power I'm using out of the 2,000 watts that are available. There's a battery monitor here. Okay, this is our Go Power battery monitor, and this is the initial startup, so I'm going to set a couple parameters. All right, this is for the amp hours, and I need to change that to 250. Okay, 250. And a solar charge controller remote here. These monitors provide all the information you need on how the systems are operating and if there are any concerns you need to be aware of. With the jigsaw, and we turn that on right here. Okay, now our WIFCO 2,000 watt inverter is turned on, so we're going to test that, and we'll just use this outlet. There's our jigsaw.
Join us again next time when we complete the interior of the van by installing the bed, cabinets, a countertop, driver and passenger seats, shelves, and more. Happy camping!